Yes, a very good morning, students. So, CUET class physics, you have only PUC second year syllabus, PUC second year syllabus only. So, around you have 14 chapters: electric charges and field, and electromagnetism part 1, and the second part optics and modern physics. In CUET syllabus में you have only second year physics syllabus. So part 1 you have which one? Electromagnetism, and part 2 you have modern physics and optics. Now in electromagnetism we have mainly in electromagnetism में yes in electromagnetism in electrostatics electric charges and field first topic electric charges and field electric charges and electric field and electric field. It is the first chapter, so in our physics syllabus, electric charges and electric field, right? So let us go for what is mean by charge. What is mean by charge? What is mean by charge? Charge is the fundamental property of the matter. Charge is the fundamental property of the matter which gives electrical and magnetic effects. In this chapter, we have mainly focus on Coulomb's inverse square law. Coulomb's inverse square law. If two charges are separated by some distance q1 and q2, two charges are separated by some distance q1 and q2, right? So what is meant by charge? It is the fundamental property of the charge. Charge measured in SI unit, coulomb. So CGS unit, electrostatic unit, electrostatic unit. There are two types of charges are there: positive charge and negative charge. Positive charge means deficiency of electron, removal of electron. Negative charge means addition of electron or excess of electrons in a body. So we can say that positive charge and negative charge. Clear? Positive charge and negative charge. What are the properties of charges? Charge has a different properties. Like charges repel each other, unlike charges attract each other, unlike charges attract each other, and charge is conservative in nature, not changes. Charge is invariant, does not change with motion. Static में, rest में, motion में, charge of the body remains same. Charge is invariant. Charge is invariant. Charge is additive in nature. Total charge of the body is equal to, we have to sum of all the individual charges. Charge is additive in nature. Charge is what? Additive in nature. And charge is quantized in nature. So it's important. Charge is quantized in nature. So Q is equal to N times of E. Charge is quantized in nature means Q is equal to N times of E. Charge is quantized in nature. The total charge of a body is equal to N times of charge of an electron, N times of charge of an electron. So N times of charge of electron means N is integer, E is the charge of an electron. So number of electrons do you want to find out? Total charge of a body upon charge of electron formula. Charge of electron formula. For example, 1 coulomb charge contains how many number of electrons? So in 1 coulomb charge is 1 coulomb. The total charge of an electron 1.6 into 10 power minus 19 coulombs. While solving this one, you will get 6.25 into 10 power 18 electrons. 6.25 into 10 power 18 electrons. So you will get, so in 1 coulomb charge, the basic very important thing, Coulomb's inverse square law. So we have Coulomb's inverse square law. If two charges are separated by a small distance, so we have Coulomb's inverse square law. See, Coulomb's inverse square law. What is Coulomb's inverse square law? In Coulomb's inverse square law, there are two charges Q1 and Q2, two charges are separated by a small distance. Q1 and Q2 are separated by a small distance r. The force of attraction or repulsion between the two charges is equal to F is equal to 1 upon 4 pi epsilon naught into Q1 into Q2 upon r square. This is the force of attraction or repulsion between the two charges. Force of attraction or repulsion between the two charges F is equal to 1 upon 4 pi epsilon naught into Q1 Q2 upon r square. Q1 Q2 upon r square. Maybe force is maybe attractive in nature, or maybe force is repulsive in nature. So like charges repel each other, unlike charges are attract each other. Unlike charges are attract each other. So this is the basic formula. Here 1 by 4 pi epsilon naught, 1 upon 4 pi epsilon naught value. So we can find out 9 into 10 to the power of 9. 1 upon 4 pi epsilon naught value how much? 9 into 10 to the power of 9. So this is, and epsilon naught is permittivity of free space. Epsilon naught is what we can call permittivity of free space. Permittivity of free space. The permittivity of free space value, what is the value of this one? 8.85 into 10 raised minus 12. 10 raised minus 12. Epsilon naught का formula. So SI Newton meter square upon Coulomb square. For this one, Coulomb square upon Newton meter square. Coulomb square upon Newton meter square. So this is the permittivity of free space. 8.85 into 10 power minus 12 Coulomb square upon Newton per meter square. So this is called, we can say that, epsilon naught, permittivity of free space. It is the basic formula. Now based on this, some applications we have to see. We have to find out net force. Net force we have to find out. To find out net force of due to multiple charges, due to group of multiple charges. So there is a one charge here Q1, there is a one more charge Q2. What is the force between these two? Force on 1 due to 2, let us I am assuming F1. Force on 1 due to 2, I am assuming F1. Let us go for one more charge we are placing Q3. So at a distance R2, what is the force on 1 d to 3? This is I am assuming F3 or F2 and so on. If any number of charges we are placing, there is no change in force between the 1 and 2. If you place one more charge, the original force should not affected. Then the net force at point O, so we can find out net force is F1 bar plus F2 bar plus and so on plus Fn bar. So this is a vector sum of all the individual forces. By using principle of superposition, we can find out vector sum of all the forces. So this is the concept of net force. Now the thing is what is the vector notation? So you can see very simple format. If it is positive charge, please listen. If it is positive charge, so दोनों separated by some distance r, both are separated by some distance r. This is the separation between them is r. Now what is the direction of the force? How to find out the direction of the force? To find out the direction of the force, let us assume that this is Q1 charge, this is Q2 charge. So the force on 2 due to 1, the force on second due to first charge, it is away from the charge. किसके वजह से कर रहा, किसके वजह से हम फोर्स निकाल रहा, वो चार्ज का ऑन Q2 चार्ज के ऊपर कौन सा चार्ज के वजह से फोर्स निकाल रहा, उसी चार्ज का दूर रहता. Force because of these two are like charges. Force on 1 due to 2. Force on किसका वजह से, Q2 का वजह से. किसके ऊपर फाइंड आउट करना, Q1 के ऊपर. किसका वजह से, उसका अवे. When like charges, like charges. Shall we go for one more vision of direction? Let us go for this is positive charge, this is a negative charge, this is a negative charge, this is charge Q1, this is charge Q2, charge Q1 and Q2. So now both are separated at some distance r, at some distance r. Now from this one what we can write, these two are attract, force on Q2, force on Q2 किसके वजह से, Q1 के वजह से. अपोजिट काइंड ऑफ चार्जेस है तो किसके वजह से फोर्स फाइंड आउट कर रहा, उसी तरफ रहता. फोर्स ऑन 2 किसके वजह से, 1 के वजह से उसी तरफ. हियर 1 के वजह से अवे, लाइक चार्जेस है तो अवे, अनलाइक चार्जेस है तो किसके वजह से फोर्स निकाल रहा, उसी तरफ रहता, उसी तरफ. सो एंड वन मोर, फोर्स ऑन 1 ड्यू टू 2, फोर्स ऑन 1 ड्यू टू 2, फोर्स ऑन 1 ड्यू टू 2 किसके वजह से निकालना, उसी तरफ, उसी तरफ, किसके वजह से, ऑन 2 उसी तरफ. It is the direction of the force, direction of the force. Find net force. How to find out net force? So let us go for one question. See here, question क्या दिया, multiple charges, there are 3 charges. Let us go for 3 identical charges, all are having charge q, are placed on the 3 identical charges are placed on the 3 corners of the equilateral triangle of side, let us assume that r. Find the net force on centroid if you are placing one test charge at point O. What is the net force on the centroid? So we have to find out net force on the centroid. So let us find out net force on the centroid. Do you want to find out ये चार्ज के वजह से, A चार्ज के वजह से और A चार्ज के वजह से, right? So let us go for this is, I call it as a B and C. Force on O due to A, दोनों like charges. Force on O due to A away, force on O due to A. Force on O due to B, it is also away, force on O due to B. Force on O due to C, it is also away because of positive charges, force on O due to C, right? Force on O due to C. Is it clear? Now check it here. Force this side is R means what is the distance from this, A distance OB, A distance OB, our A distance should be same. So OA is equal to OB is equal to OC, OA is equal to OB is equal to OC, that is equal to, we can write, so from side R है तो A distance R by root 3, so that should be equal to R upon root 3, R upon root 3. Then we want to find out force between net force, the resultant force of these two. You make sure that, so we need parallelogram law. So if two vectors A bar one vector or F1 bar one vector and F2 bar another vector, so both are makes an angle theta, both are making an angle theta, both are making an angle theta is visible right now. So both are making an angle theta. Then the net force we want to find out. The net force is here, F net is equal to F net force according to parallelogram law under root of F1 square plus F2 square plus 2F1 F2 cos theta, 2F1 F2 cos theta. So let us go for, if theta is equal to 0, if theta is equal to 0 degrees, so if, and both F1 also equal to F2, theta 0 and F1 equal to F2 and F1 is equal to F2, that is equal to F condition, F1 is equal to F2, that is equal to F. When theta is equal to 0, resultant force is 2F, resultant force is 2F. When theta is equal to 60 degrees, the resultant force is root 3 times of f. Make sure that f1 is f, f2 also f, f2 also f, f2 also f, f2 also f. So let us go for, if theta is equal to 90 degrees, resultant force is root 2 times of f, root 2 times of f resultant force. If theta is equal to 120 degrees, 120, the resultant force is f only. The resultant force is f only. If theta is equal to here 180 degrees, 180, the resultant force is 0. It is the vector notation, parallelogram law. Parallelogram law. Parallelogram law. Right? Let us go for, now solve it this question. Please, very आसान question है. Now check it here. See, this one what we can write, इसका force कितना हो जाता, K Q into Q naught upon, so let us, I am assuming x square, AB x, AB also s, it is also x, K Q naught upon x square. Direction already I shown. For this one also K Q naught upon x square. Both are equal forces. What is the angle between them? 120 degrees. The angle between them 120 degrees means resultant force is either of the force. So the either of the force, this direction resultant force, this is F. ये F है तो this is F है तो the resultant force also F. If it is F, this is also F. It is also F. This is also F. Then the net force both will be opposite 180 degrees. Net force is equal to 0 हो जाता. So the force at the centroid में net force कितना हो जाता? 0. The net force on the centroid is 0. Very आसान है. Very simple question. Let us go for one more question. What we have to do here? One more question, please. What we are doing? Let us go for, there is a equilateral triangle. Two charges are placed at two corners. Two charges are placed at two corners. Find the, or three charges are placed at three corners. Find net force on any one of the charge. Of each side is R. Each side is R. I am assuming at point C I want to find out net force. Let us go for point C. We want to find out net force. So let us, I am assuming A point. This is B point. So A to C both are, कुछ भी साइन नहीं दिया बोले तो उसका मीनिंग क्या है? पॉजिटिव चार्ज. इफ इट इज नेगेटिव चार्ज डेफिनेटली साइन देते. सो कुछ भी नहीं दिया बोले तो दैट शुड बी ए पॉजिटिव चार्ज. नाउ ये चार्ज के वजह से इसके ऊपर फोर्स ऑन सी ड्यू टू ए, फोर्स ऑन सी ड्यू टू ए, फोर्स ऑन सी ड्यू टू बी, फोर्स ऑन सी ड्यू टू बी, force on C due to B. Force on C due to A, how much you will get? Force on C due to A, it should be K Q into Q square upon R square. Force on C due to B also कितना? K into Q square upon R square. Both are same. So all sides are same means this is the equilateral triangle. This angle will be 60. Then this angle also will be 60. If it is 60 means equal forces means what I said, root 3 times of F. The net force at point C, the net force at point C is equal to root 3 times of F, where F is equal to KQ square upon R square. F is equal to KQ square upon R square. This is the net force, net force. Is it clear, students? Net force. So let us go for one more last problem on this Coulomb's law. There is a square. There is a square. There are four charges are placed on four corners of the square. Four charges are placed at four corners of the square. Four charges are placed. each side is r, each side is r. Find the force on any one of the charge. Find the force on any one of the charge. So let us go for it is, I am assuming point A, point B, point C. This is point D. D to A, force on D, D to A, force on C, force on D, D to C. So force on D, D to B. We'll see you later that one. First one, this one, what we can write, k q square by side r hai to k q square by r square. Now force this one, k q square by r square, k q square by r square. So these two forces are perpendicular. Perpendicular means what you will get, root 2 k q square upon r square. Just now I have given parallelogram. Two are perpendicular and equal means root 2 times of either of force. And one more, d to b के वजह से what is the force? d to b के वजह से force d to b k q into q square upon this distance root 2r. Root 2r square means 2 times of r square. Both are same direction. When both are same direction, the net force on D, here. So what is this? Net force on D. So how much net force? Root 2 plus 1 by 2 times of k q square upon r square. K q square upon r square. This is the net force on point D. So this is the Coulomb's inverse square law. Please note down Coulomb's inverse square law. Okay. Shall we go for electric field? The next topic is what? Electric field. Before entering that electric field, so what we want to require? See, what is meant by distribution of charge? Distribution of charge. There are three types of distribution of charge: linear distribution of charge, linear distribution of charge, linear distribution of charge, linear distribution of charge, linear charge density. इसमें क्या है फर्स्ट वन? सो लीनियर चार्ज डेंसिटी एक, लीनियर चार्ज डेंसिटी. So the charge is distributed along its length, then that is called linear charge density. So linear charge density denoted by letter lambda. Lambda is equal to dq upon dl. Charge is distributed along its length. When total, we can consider lambda is equal to q by L. So this is a charge coulombs. Length is in meter. Coulomb per meter. That is a linear charge density. The second one, what we can write? The second one I am talking areal charge density or surface charge density. Surface charge density. What is meant by surface charge density? Surface charge density denoted by a letter sigma. Sigma is equal to charge per unit area. dq upon dA. Charge per unit area is called surface charge density. इसका unit coulomb per meter square. So now let us go for volume charge density. This is volume charge density. Volume charge density. So when volume charge density means, so rho is equal to dq upon dv. So this is called volume charge density, dq upon dv. So charge per cubic meter, or we can write q by volume, q upon area. Q upon area. So this is called distribution of charge. Linear charge density, surface charge density and volume charge density. Shall we go for finding about which one? Electric field. Electric field. What is mean by electric field? The space around the one positive charge or negative charge. The space around the positive charge or negative charge, there is a space around this positive charge. This space is called electric field. Or there is a negative charge around this negative charge, the space around the negative charge. The space around the negative charge which influence is felt, that is called electric field. This region को क्या बोलते हैं? Electric field. ये space it is extended in the form of imaginary lines. In the form of imaginary lines, those lines are called electric field lines. So the space is extended in the form of imaginary lines. Those imaginary lines are called electric field lines. Electric field lines. If it is a positive charge away from the charge, if it is a negative charge toward the charge, इलेक्ट्रिक एक चार्ज के पास कितना दूर तक उसका इफेक्ट रहता उसको क्या बोलते? इलेक्ट्रिक फील्ड. पॉजिटिव चार्ज है तो अवे में रहता, नेगेटिव चार्ज है तो टुवर्ड्स में रहता. इलेक्ट्रिक फील्ड. Electric field is a vector. How to define mathematically electric field? How to define? If it is positive charge and negative charge समझो. So positive charge में start होता, negative charge में terminate होता. Positive charge में start होता, negative charge में terminate होता. So away from the positive charge हो रहा, so towards the negative charge. Positive charge से away हो रहा, नेगेटिव चार्ज को टुवर्ड्स हो रहा, नेगेटिव चार्ज को टुवर्ड्स. सो दिस इज द इलेक्ट्रिक फील्ड लाइंस ड्यू टू आइसोलेटेड पॉजिटिव चार्ज, ड्यू टू आइसोलेटेड नेगेटिव चार्ज एंड ड्यू टू इलेक्ट्रिक डाइपोल बोलते हैं इसको. पॉजिटिव एंड नेगेटिव चार्ज को इलेक्ट्रिक डाइपोल. इलेक्ट्रिक डाइपोल. यस, राइट. नाउ शैल वी गो फॉर how to define electric field? Electric field which is denoted by E letter. Electric field कैसा define किया? Force on unit charge. Force on unit charge को क्या बोलते? Electric field. So force is Newton, charge is Coulomb, Newton per Coulomb. Newton per Coulomb is the SI unit. Force on unit charge is called electric field. Electric field. So इसमें से force F is equal to Q times of E. Force F is equal to what? Q times of E. This charge is positive, force is along the field. Charge is a negative, force is against to the electric field. Force F is equal to Q times of E. Force F is equal to what? Q times of E. So this is the electric force on a charged particle. On a charged particle. Now what is mean by electric field? If it is due to positive charge along the field, negative charge against the field. For example, this is electric field. एक charged particle इधर रखा, force along this direction QE. If there is a one more charged particle minus Q इधर रखा, force is against to the electric field. Force is against to the electric field. Against to the electric field. Now this one, what we can write? What we can write? Which one? Electric field due to a isolated point charge. Electric field due to a isolated point charge. So due to isolated point charge, there is a one charge plus Q. Due to this point charge at a distance R at point P, we want to find out electric field. Electric field due to isolated point charge E is equal to 1 upon 4 pi epsilon naught into Q upon R square. This is the electric field due to single charge. Electric field due to isolated positive charge 1 upon 4 pi epsilon naught into Q upon R square. You know that this value it should be 9 into 10 to the power of 9. So जो charge दिया for example 10 microcoulomb charge has given, so 10 into 10 power minus 6, or the distance has given 1 meter, the distance has given 1 meter in case. So what we can find out, the distance has given 1 meter, 1 square, so 9 into 10 power plus 6, 6 cancel, 3 plus 1 4, 9 into 10 power 4 Newton per coulomb. This is the electric field at that point. So electric field at that point, we have to find out electric field at that point. This is the electric field. So to find out electric field due to isolated positive charge. So and one more thing here, due to positive charge है तो electric field at this point, electric field due to negative charge, electric field at this point due to positive charge away from the charge, due to negative charge it should be towards. Due to negative charge electric field is towards, due to positive charge electric field is away. Due to positive charge electric field is away, due to negative charge electric field is towards. The same thing we have to applicable, which one, previous one what I said. So on स्क्वायर क्यूब सेम फिनोमेना, फील्ड का फोर्स का डिफरेंस क्या है, फील्ड इज ड्यू टू सिंगल चार्ज, फोर्स इज ड्यू टू मल्टीपल चार्जेस. फार्मूला आल्सो सेम, q1 q2 upon r square, q1 q2 upon r square, but here only q upon r square. Now one more thing, do you want to draw the graph whether force or field versus distance graph ड्रा करे तो, electric field versus distance graph ड्रा करे तो you will get hyperbola. You will get which one? Hyperbola. So because E inversely proportional to R square, E inversely proportional to R square, electric field is inversely proportional to R square. So that region E inversely proportional to R square means hyperbola. 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 Yes. So this is the process of hyperbola. This is electric field. So okay, we'll continue in the next session. So next session, electric field, what is the torque, electric dipole, what is electric field due to dipole, what is electric field due to dipole, and what is the Gauss theorem and इसका applications क्या है. So we'll discuss in the next session. Thank you.